like 3 o'clock yesterday, I would print them out again, make sure you get the correct one. Some of you have different versions of the book other than the 4th edition, which is what I have. Use the homework problems that are scanned in then. I don't mind if you have different editions of the books, but for the grader, you have to have the same homework problems. Any questions about that? Okay, good. So now, the median and the mean. The mean is a typical value. It's also a measure of center, and the median is the true measure of center. It's the center of your data. So let's do an example where we calculate this. So after 10 minutes of exercise, the doctor observed how long it took for each of his patients to return to a resting heart rate. So the time to resting heart rate was measured. Time to measure resting heart rate is a measure of how fit you are. The fitter you are, the faster you return to your normal heart rate after exercise. And the data collected was for 8 students. 5 minutes, 7 minutes, 5 minutes, 8 minutes, 4 minutes, 12 minutes, 4 minutes, 3 minutes. So we're going to calculate the mean and the median for this data set. So first thing, if you ever see me asking for a median, or in just a little bit we'll do quartiles or quantiles, order the data. So ordered just means from lowest to highest. 3, 4, 4, 5, 5, 7, 8, and 1. So since I have 8 observations, this means n is equal to 8. So calculate y bar and y tilde. In other words, the mean and the median. The median is easier to calculate, so we'll do that one first. So for median, first you calculate n plus 1 times 0.50, which is going to be 9 times a half, which is 4.5. Oops. Yeah, I know, I already tried that light. I don't know why the lights are off. We have like 6 light switches down here. None of them turn on the back row. We had this problem once in the summer as well. I have no idea. So I apologize for that. So now, according to my rules, if a number has a decimal, which mine does, I round up and down. So y tilde is the average of the 4th and 5th, so that's rounding down and up, value of the ordered data. So that is equal to, so you go to your data, count 1, 2, 3, 4, 5. They both happen to be the value 5 in this case. So it's 5 plus 5 divided by 2, which of course is just 5. So that's what I mean by round up and down and take the average of those 2 values. This is what I call the rounding rule, because we use it for many other things than the median. Some of you may have learned how to calculate quantiles and medians before. I expect you to use my way on the exam. So this is basically so the grader doesn't have to figure out which method you use and see if you did it right. So y bar, on the other hand, we add up all of our values. So 3 plus 4 plus 4 plus 5 plus 5 plus 7 plus 8 plus 12 divided by n, which is 8. So this gets us, if you add all those up, those are 48 over 8, and that's 6. So the typical value in our data set is 6. The actual center of our data set is 5. So the way we can look at that is the median is the value for which 50% of the data lies above and 50% below. So there's a couple ways we could count this. So our median is 5. So you could go 5's in between itself and go 1, 2, 3, 4 below and 1, 2, 3, 4 above. Or you could just not count 5 and then you have 1, 2, 3 above, or sorry, below, and 1, 2, 3 above. So it does split the data exactly in half. There's some other cool things about, or comments or notes about the mean and the median that I want to go over. So notes about y bar. these are things, I'm sure you've all calculated the mean, heard of the mean, but maybe you haven't thought about these particular things about the mean. So 1, the mean gives equal weight to all observations. In other words, each observation is equally as important as any other. So the mean gives equal weight to all observations. So this is, in a sense, good. In another sense, it can be troublesome. So this means that if I have an unusual value in my data set, so here I don't really have any values that particularly stand out. 12 is kind of high, but not really higher than anything else in the data set. But if, for example, I had a 34, that would be unusual. And the mean would give that as much weight as everyone else. So the second note is the mean is highly affected by unusually large or unusually small values. And unusually large or unusually small values are also called outliers. And we'll be specific about how we identify them in a little bit. But you can also say they are largely affected by outliers. So this can be bad. It's particularly bad for data such as house prices. So house prices in, you look at a histogram of house prices in Vacaville, there weren't very many high-priced houses. But if there were one that some households could find in, it would drag the mean up towards that value, which really wouldn't be indicative of what overall is happening in your data set. So if you have large or small values, you want to be careful with mean. And the last one is just a definition the deviation from the mean for a value yi. This will come in handy in a little bit, is you take that value and subtract the mean. It also has a very nice property, which is that the summation, so if we add up all the deviations of our data from the mean, that would be 0. So this is evidence that this is, in fact, a measure of center for your data. If you add up the distance from your data points to the mean, you get 0. That's going to become helpful later on, but those are just some things we should be aware of if we are choosing if we're going to use the mean or the median. So now what about the median? So notes about the median. Are there any questions about the notes for the median? Sorry, go on. Good? Yes?
Could you explain what the third one is again?
Yeah, the third one, so the third one is, once we've calculated the mean, we can calculate the distance from the mean for any of our data points. So for example, 12. The distance from that data point to 6 is positive 6. So it's kind of far away from the mean. But if we calculate all those distances or deviations and add them up, it's 0. And in this way, lots of people like it because it's a measure of center. If you add up all the distances, they come to 0, so it's about the center of your data. I'm not going to really have you guys use this very much. It'll come up a little bit on Friday, because we'll talk about standard deviation and why that isn't good to use in standard deviation. So this is just more of a definition. So what about the median? The median is not affected by unusually high or unusually low values. So 1, median is not affected by outliers, in other words, or not highly affected. It could be very slightly affected, but not much. But, so that's fine because it's taking the middle two numbers. So out of your whole data set, all it looks at is the middle two numbers. So if I added a 47 up here, the median wouldn't change very much. It actually would still be 5. But on the other hand, why people sometimes don't like using the median is it doesn't take into account or doesn't give equal weight to all of your data. It only gives weight to the middle two. So it does not weight all observations equally. Okay. So that can be problematic because some people may argue, well, it's not taking into account all the observations of your data, so maybe it's not a good indicator of the typical value of your data, which is a perfectly reasonable argument. But for things like house prices, the median is very useful because it'll tell you, one, that 50% of house prices lie below this value, 50% are above, and is not affected by outliers, so that won't pull the median towards the higher values like the mean does. So now I have a question. Does the mean and the median, the values for the mean and the median, have to be in your data set? Be in your data set. So true or false? The value for the median must be in your data set. No. In fact, it doesn't even need to be a realistic number. And what I mean by that is, if you were counting number of things and you got a median of 4.5, that would be okay. Because the median isn't something that we expect to measure. It's just where the middle of the data is. If it's 4.5, that's okay. So the median can be a decimal, and does not have to be in your data. So n does not have to be a value in your data set. The same thing is true for the mean. So the mean is you're averaging a bunch of things, summing them up and dividing by the sample size. So that could very easily be a decimal. It also could very easily not be something in your data. I don't believe we had a 6 in our data. We had 4s, and we had 3s and 5s. So that's an example where it doesn't have to be in your data, but it still makes sense to talk about. So same is true for the mean. You had some homework problems on this, or a homework problem, I should say. So now you can answer that. It's okay to talk about a person owning, on average, 2.5 cats. That means that lots of people own 3, lots of people own 2 on average, because average is what happens in general, 2.5. It's like you have a house with 2.1 kids or 2.5 kids. That's okay to talk about. So any questions about the mean and median so far? Yes?
So the whole rounding up and rounding down,
yes.
And do we have to do that in this case as well?
If the mean?
Yeah.
No, that is specifically for the median because you're finding the median is a position in your data set, but if you don't have an odd number, the middle of your data set is in a certain position. It's actually the average of 2 numbers. So we had 8, for example, so if I try to find the middle of 8 points, well, it's not here because that's uneven. It's not here because that's uneven. It's actually right here, which is exactly what the median is doing. But if I have 9 points, and that's why we round up and down. So it'd be here and here and average for 2. If we have 9 points, there actually is one data point that's exactly in the middle, has exactly the same number above and below. The mean, we don't really have to worry about that. Good question. Okay. So we can also so we separated the data by half with the median. Half above, half below. We can also do quarters, which are also very popular. So quartiles, or quantiles sometimes, divide your data into quarters. So when we, quarters is not spelled like that at all. When we split the data in half, we had one value to split it in half. So if we're split it into 4 parts, which would be quarters, we're going to have 3 values to do that. So they all have special names. And we actually use them in one of the plots that we're going to have to do by hand in this class. The only plot we'll have to do by hand. But, so the quartiles. Q1 is how it's denoted, is the lower, or sometimes called first quartile. So 25% of the data lies below it, so that's the first quarter. So that means that 75% lies above. So again, you may have learned different ways to calculate this. This is the way I want you to calculate it because it's very similar to the way you calculate median and also percentile. So to calculate Q1, so step 1 or first calculate, n plus 1, but now we don't want to split it in a half, we want to split it in a quarter. So it's times 1/4, which is the same thing as saying n plus 1 times 0.25. So now we follow the same rounding rule. So follow the same rounding rule. If it's a whole number, you just leave it alone and pick the number in that position of your ordered data. If it is not a whole number, you round up and down and average the two. So one of the other ways to calculate it is to split your data in half and calculate the median for each half. That sometimes doesn't give the same number as this, so please use this way. Similarly, Q3 is the upper or third quartile. And 75% of the data lies below that, which means that 25% must lie above. Same rounding rules, but now, first calculate. It always starts with an n plus 1. But what do you think is going to go here now? Yes, 3/4 or 75. Good. So that's why I like this. It's very intuitive. If you remember one formula, all you need to remember is you change this to however many values or whatever percentage is below it. So the same thing is n plus 1 times 0.75. Q2 is the middle quartile. Well, what is that really? The median, right. So Q2 is just y tilde. So Q2 is y tilde. We use the same notation, has the same meaning, calculated in the same way. So for example,
is a quartile, is that a portion of the data or is it a point?
It is a point. It is a point. They call it a quartile because you know that it splits the data into a quarter. So for example, the first quartile, so why it's called a quartile is here's our number line, here's our data set. This is Q1, Q2, and Q3. And it splits it into quarters. So you know, for example, that here's 25%, but you also know between Q1 and Q2 must be 25%. You also know between Q2 and Q3 must be 25%, so it splits it into quarters. Of course, you can also find the middle 50% of your data, which would be Q1 to Q3. But for now, that's why they call it a quartile. It's also called percentiles, which we'll get to a little later. Any other questions? Okay. So example, pulse rates. 12 college students. Were measured. So they randomly selected 12 college students and they found their pulse rates were 62, 64, 68, 70, 70, 74, 74, 76, 76, 78, 78, 80. So I've already ordered this for you. Which if I give you more than 8 points on the exam, I will typically do. Like if I give you 20 points, they will already be ordered because you all know how to put things in order. But on the exams, you make silly mistakes, so maybe you did it wrong and then all your numbers are wrong. So, Let's find Q1, Q2, and Q3. So find Q1, Q2, Q3. So Q1. First you calculate the n plus 1 times 0.25. So n plus 1, times 0.25, which is the same as 13 times a quarter, which is not going to be a whole number. It's going to be 3.25. So Q1 is equal to the average of values, since this is not a whole number, in third and fourth